Good morning, everyone, and welcome to the Python session. This is our first session. In this session, we are going to see how to go about installing Python, the setup part of it, and the various graphical user interface that we have to work on Python. So, before we get into the Python session, what is the content? What is the agenda of today's session? We'll have an introduction to Python. What is Python? Why Python? Then installation of Python. Anaconda is what we are going to install. Then we are going to discuss three graphical user interface. One is idle, second is Spyder, and third is Jupyter Notebook. And finally, we will see, besides the base installation, if we have to install any new package, then how do we go about installing new packages in Python? That's the agenda for the installation and setup session. So, what is Python? Python is a high-level, general-purpose, interpreted, dynamic programming language. The most important here is interpreted. So let us try to understand what do we mean by interpreted language. If you are aware of programming languages like Java, C, C++, what happens is you write a code. The code that we write is a high level language. The high level language because it is human understandable language. So that's why the first point, high level, and is general purpose. Python is general purpose because it can be used for variety of purposes. Python can be used for web development. Python can be used for API creation, programming, and many other elements. So that's why it is a general purpose programming language. Now coming to the interpreted, we write a Python code. Typically in Java or C, you write a code. In that case, first you have a compiler. The compiler compiles the code and gives you a byte code, which is typically a machine code, which is understandable only by the machine. So from high level language, it goes to a low level language, which is the machine language. And from machine language, you run the program, and the compiled code you actually run it, and you get the result. So that's the way a typical code execution happens with Java, C, C++ kind of a programming language. However, in case of Python, Python is more like a scripting kind of a language where you do not have the compiler in between. You write the code, and the extension of a Python file would be a .py file, and then you pass it to an interpreter. The interpreter interprets it and gives you a result. So basically there is no compilation step in between. Okay, so that's why it is called a interpreted language. And Python is also a dynamic programming language. Now, why dynamic programming language? What is dynamic? Basically what happens is you can have variables, and the variables or objects which can take value depending upon the value that it has got at the runtime level. So basically you can have loopings, and when which in a looping the value of the variable can keep changing, or depending upon what data you are processing, the value can change, and that changed variable you can directly take into your logic. So that's why it's a dynamic. So Python is a high level, general purpose, interpreted, dynamic programming language. The second element is Python is also referred as object oriented scripting language. The first thing is scripting. Typically the websites that we see when we open a web page, the page behind used to be typically a HTML. Even if when we write a JSP or a ASP, finally the display happen through HTML tags. And HTML is a scripting language wherein the entire code is written in an editor, like a script. Okay, as a film script, basically a script according to which the code gets executed. Okay, so similarly, Python is a scripting language. At the same time, it supports functionalities of object-oriented programming, which is like Java and R. It supports elements like inheritance. It supports elements like polymorphism. We need not go much into details of all of those object-oriented programming because for data science point of view, we need not know very in-depth element of it. But at a high level, Python is also referred as a object-oriented scripting language. And it supports all the programming paradigms like object-oriented, functional, and procedural concepts in Python. The design philosophy of Python is simplicity and code readability. Okay, so the entire code is very readable and simple to write. That's the design philosophy by which the Python has been written. Python code can be run on system having a Python interpreter. So what is most important is when you run a Python code, you require a Python installation, that is the interpreter of Python, to be available on your machine. So that's what we are going to see as part of our installation procedure. Alternatively, in case we do not want someone to have the full-fledged Python installation to happen, which is typically required by a developer. So in case we do not want a full-fledged Python installation, we can create a standalone executable program of it, which can be then interpreted on systems not having Python interpreter. So there is something called standalone executable program that we have to create from our code and then give it to the other person who have to consume it or use it. Okay. Why Python? Python is free. Python is easy to learn. It is a high-level language. We just learned what is high-level language, programming in which we write as a human being, which is easily understandable, not the machine code, which is in bits and bytes, right? Cross-platform runnability. Python programs can run on Mac, Windows, Unix, Ubuntu, across different platforms. So cross-platform runnability. Extensive open source libraries. Python is open source. There are extensive libraries and modules written by people like you and me who are contributing to the growth of Python. Okay. Language interoperability. Now, what is language interoperability? In a Python code, I can have R code running. In a Python, I can have a C code running. So basically, it can allow other programming language code to run in their native system. So it can support codes written in other languages to become part of it. So someone is efficient in writing code in C, so that person can write in C, and someone who is doing Python programming, he can give his module, his component or her component written in C to this person, and you can then merge the two and create the final outcome, final program. Extensive set of data structures. Python supports many data structures which are required for machine learning. It supports arrays, it supports matrix, it supports data frames, various kind of object data structures which are required from a data analysis point of view. It supports all of them. It can be used to do anything like, as I mentioned in the previous slide, it's a general purpose programming language. So Python can be used to do a website development. Python can be used to create new graphical user interface. Python can be used for network programming. Python can be used for data analysis. It can be used for machine learning. It can be used for scraping of data from websites, it can be used for natural language processing, and so on. It can be used for many other purposes. That's the reason why Python is called a general purpose programming. Okay, so this is what and why. And finally, from our standpoint, why Python is important. The reason Python is important is in data science, in machine learning, there are three prominent tools. One is SAS, second is R, and third is Python. And most of the time, people who work on R programming, they develop the entire module, they do the entire analysis, but many a times the final implementation, where there is a large amount of data, the final implementation ends up being done in Python. So from that standpoint, it is very important for us to understand Python programming. Different versions of Python over time, there have been many versions which has been released. You can see the first edition was released way back in 1990, and over time we are currently having 3.7.0, which was as on June 2018. So probably there may be a new version that would have already come up by now as we speak. Okay, so that new version we will see on the website and as we go about doing the installation. So now we see the installation part of Python. How to go about installing Python? What we are going to do is we will do Anaconda installation. So the first step is we have to go to the website anaconda.com and we'll have to go the download part of it. So this is the anaconda.com website distribution. If you scroll down, you will see Python 3.7 and Python 2.7 version. For a good amount of time, despite the release of Python 3.7, people were continuing to use Python 2.7, and still there are many people who continue to use Python 2.7. The reason is the code written in Python 2.7 is not fully compatible with Python 3.7. So one thing that we have to be very particular while working with Python is the version that you are using, because the new version 3.7 is not very compatible with the older version. So many codes that you would have written in Python 2.7 may not run in 3.7. Okay. Of late, any new development that is happening on 3.7. So we are going to use Python 3.7 or the higher version, whichever is the latest available. Depending upon the operating system, you have various installers. So here it says Anaconda 2018.12 for Mac OS. Probably I'll have to click Windows. So now it says Anaconda 2018.12 for Windows. In case you have Linux, you have to click on Linux. So depending upon your operating system, kindly select the installer and click on download. So as you download, the download is going to start. In my machine, the Python Anaconda is already installed. As such, I'm going to cancel the download process. However, in your machine, it might not be installed. So in that case, you may have to download the installer. By 2020, the support for Python 2.7 will be stopped. As such, anyone starting with new developments in Python should do in 3.7 or higher version. Moreover, if someone has already have programs which are written in Python 2.7, in that case, you may have to do a complete code review, functionality testing, application testing if you are migrating from 2.7 to 3.7. As I already mentioned, 3.7 version is not fully compatible with 2.7 version. So once you have downloaded the Python based on your operating system and uh, the bit of your computer, typically most of the computers are nowadays 64-bit. If your machine is a 64-bit, ensure you download 64-bit because it would be faster in processing. In case your machine is a 32-bit, then in that case you will have to go for a 32-bit installer. Then the steps are very simple. You will get a exe file. You have to double click the executable file and follow the instructions. On successful instruction, you will find Anaconda prompt in the start menu. So basically, after having installed, I type Anaconda, you see this Anaconda prompt will be available. You can navigate like this. Sorry, Anaconda 64-bit. So here you can see lots of components available, lots of application of Anaconda which is already installed. You have got an Anaconda navigator which helps you navigate to many other sub applications which are installed as part of the Anaconda installation. Okay. In case you have done the installation through Anaconda, you need not install Python separately because Anaconda provides, along with the graphical user interface, it also provides the entire set of libraries of Python, and not just the basic libraries of Python, it also provides many other libraries which are commonly used that automatically gets installed as part of the Anaconda installation. Just in case someone do not want the full Anaconda to be installed and just someone wants only the Python to be installed. In that case, you can go to the Python website http://www.python.org. You can go to the website, click on the downloads menu, select Python 3.x. 3.x is any version which is above 3. Currently it is 3.7. So we take that based upon the operating system, double click on the Python exe, and you get the Python installed in your machine. So this is here. So Python. Go to the Python, and latest it says is 3.7.2. So it's just detailing what are the new features in Python 3.7. So Windows user, the binaries for also work on processor, Mac users, and here are the various downloads. So these are the downloads available. Depending upon your operating system and the bit, you have to select the download. My suggestion is we should install Anaconda. One, it provides you very good graphical user interface. It provides you Spyder. It provides you Jupyter notebook, These two graphical user interface are very useful and we are going to see it in detail. If you just install the basic version, in that case you will have the graphical user interface which is idle, IDLE. It is not that user friendly for someone to work on Python. Okay. Okay, great. So by now, I'm sure all of you would have the Python installed. In case and Anaconda also installed. In case Anaconda is not installed, pause the video if you're seeing it online. Okay. So let's move to the first graphical user interface, idle. In case you have just installed Anaconda, idle interface may not be available. However, you may check whether idle is available or not by typing IDLE in your runtime box. So when I run IDLE, you see I see Python 3.5 32-bit. However, in my machine, Anaconda is actually 3.7 version. How do I know it's a 3.7 and it's a 64-bit? So here you can see Anaconda is 64-bit. So when I installed Anaconda, idle will not be available. So here, anyways, I'll show you the idle environment. I type idle and open it. Yeah, ideally, this is the kind of interface IDLE is going to provide you. Okay. The two key components of the Python installation are the interpreter and support libraries. When you install Python, some basic support libraries are required to run it. So those get installed. And the interpreter, because the way Python code gets executed, it's an interpreter language, right? So you write code, you run it through, interpreter will process it, understand it, and you get an output. So what do you mean by interpreter? I say a is equal to 10. A. I run the code on the console. At the runtime, at the moment I run it, it is processed and the information captured in some variable a. When I say a, it displays me the value 10. There is no code which is now available that I can take that code and give it to you saying this is a package which I have created, so you can just run it. I have to run the code through a scripting process only. That's why Python is an interpreter language. In the same sense, R programming that you learned is an interpreter language. What is an interpreter? It is a layer of software logic which interprets your Python program before it gets executed on your computer. So let us see the code execution steps. What happens? The first step is you write a code. Typically, when you write a code and you save the entire script, you save it by a .py extension. When you compile it or when you run it, a bytecode file, a low-level language which is platform independent, is created. And that gets executed in the Python virtual machine, which is the runtime engine of the Python. So 3 steps. First, you write a code in a high-level language. Typically, the script, Python script, you store by a .py extension. When you compile it, that is basically the interpretation happens. When you compile it, a bytecode which is a low level language outcome, the extension of that is .pyc. Okay, that is generated, and then that .pyc, that is the byte code, is sent to the Python runtime engine, and the Python runtime engine then interprets and gives you the output. That's a process of code execution in Python. Let us create a script. So I say file, new file. So I've got a editor. What was the behind screen? Actually, it was a console. This was a console. Here you directly run the code. This is basically editor. A is equal to 10, B is equal to 20, C is equal to A plus B, C. You do not have any shortcut by which you can directly run it. So in that case, you will have to copy and paste it on the console. So it says there is a multiple statements found while compiling a single large statement. Okay, sorry. So I'll have to run it step by step. A equal to 10, B equal to 20. This is a basic challenge of working with the IDLE environment. And C, which is cumbersome. The other way of running it would have been run and then say Python shell. So it is going to create a new shell, a new kernel, basically a new console. Okay, so let me save it. I'm saving it by a.py file. Save. And the moment I saved it, it says here restart this thing, and the code got executed. The entire code got executed and I get the value C outcome directly. Here let us say D is equal to C. If I type D here, it says there is error. Once again, what I do is run this entire thing first. Let me save it, because again it is going to say it has to be saved. So run module. This entire file, I'm going to run it. It says restart. The kernel gets restarted. I said D is equal to C. Okay. So either if you're working in an IDLE environment, the entire file gets executed, or you have to do copy, paste. So this is a challenge of working with the basic user interface IDLE, which comes with the Python installation. We are going to use, for our training purpose, we are going to use Spyder or Jupyter. Okay. There are multiple Python implementation that we have. So basically there is something called a C Python, which is written in C. There is a J Python, which is written in J. There is something called Iron Python, which is written in .NET framework. There is something called Stackless Python. There is something called PyPy. At this level, I don't feel that it is very important for us to know which Python interpreter we have. And we should not be worried about which Python interpreter has got installed along with Anaconda. At a later stage, as speed might be a very important element, processing speed, at that time probably we may have to think of it. Okay, so here for example it says PyPy. PyPy is a fast, compliant alternative implementation of the Python language, and thanks to its JIT compiler, just in time compiler, Python program often runs faster on PyPy. So that is a later stage. At this stage, as we are just getting introduced to the subject, if we just want to know what is the platform on which our Python is installed, on which our Python is developed, in that case we just import a package Python, import a library platform and see the version. What is library? Codes are actually created in modules. The entire code is not written in one file. The code is broken down into smaller files. So different libraries provide you different functionalities, and one of the libraries is a platform which tells you what is the implementation. Is it based on C? Is it based on Java? So let me import the platform library. Import platform, and the next command is platform.python implementation. From this library we are calling the function Python implementation. This is a function. So here you can see the Python implementation that we have is CPython. Okay. All of you kindly check what is the implementation of the Python that has been installed on your machine. You have Anaconda, you do not have ideally. In that case, what you can do is you can search Spyder and click on this Spyder desktop app. It should open the Spyder app in your machine. In my machine, it does not open directly this way, and in case someone has difficulty by clicking on Spyder icon and if it does not open up, the other approach is you open an Anaconda prompt and here you type the word Spyder and run it. So I've given two options: start, run, type Spyder. This desktop app Spyder, something of this kind, because it's installed on saying as a desktop app. If you run it, it should launch Spyder. In case it does not launch Spyder, in that case run Anaconda prompt and from Anaconda prompt you type Spyder and you will see the Spyder opening. So here the Spyder has got launched in my machine. Okay, so here I'm going to import platform, and then in Spyder you have a shortcut. Here I have written the syntax. I select it, control enter. You see the console. This part is your editor. This part is your console. So the moment I select and run Control Enter, the code gets executed on the console. The second benefit of it is it provides auto prompt. This autocomplete functionality. Anaconda, in Anaconda Spyder, I am running this and I get the outcome here also. The implementation is C Python. Okay, the other way of running the code is basically, say my cursor is blinking somewhere here. I just press F9 and you see on the console the syntax has got executed and my cursor moves down automatically. I'm again going to press F9 and my cursor goes to the next line. I once again press F9. So the other way of running code on Spyder is by pressing the F9 button. So far we have just got introduced to the Spyder environment. We'll now take a quick break, and in the upcoming session we are going to see how to work on Jupyter and basically what are frozen binaries. Okay, thank you.